this section is going to be talking about observational studies and experiments, and then a few extra vocab words to make sure that we're understanding what's good and bad about those two main forms of research. So an observational study, really the key word there is observational. The idea here is that we are passively observing what is happening. So we don't like force people to like go on a certain diet or some other diet, right? We're just passively observing their diet choices and what they do with it, right? It doesn't have to be about diets. I'm just saying as an example, we're not influencing what the variables are, right? Right? These first studies, and actually all studies where we've looked at smoking's link to lung cancer, are observational studies. And here's why. We were just passively observing whether someone smokes or not and whether or not they got cancer. We did not go tell anybody, okay, you group over here, you're going to smoke cigarettes. You over here, you're not going to do that, right? That would never work in the first place. It'd be unethical, right? There's so many issues with that. We really can't do that. And so we're kind of stuck with this observational study. And one of the earliest criticisms of that research, right, as it became more and more obvious that tobacco smoking causes some serious issues with lung cancer and other outcomes, was that, oh, well, people that smoke tend to drink more, and it's actually the alcohol that's causing the problem, not the cigarettes. And to be honest, I don't know that any of that part was true, but that is a valid criticism of observational studies, is that many times you don't know what variable actually caused the change here. And we had to come up with a word for this because it happens so often. It's called confounding. When two or more possible variables could have influenced the outcome and you can't really tell which one it was. So I've given an example here of a study might find that people who meditated regularly were less prone to heart disease than those who didn't. All right, so we actually see these kind of studies quite often with alternative medicines. And here's some criticism that you might see for something like this, right? The idea here is, oh, meditation made you like calm, and so, you don't get heart disease, which may or may not be true. But if we're just doing an observational study instead of an experiment, which I'll talk about in just a moment, we don't actually know whether it was the meditation necessarily or the type of people that do meditation have lower incidence of heart disease. So as just some examples that I see a lot in these criticisms, one would be, if you go meditate, you have the time and the money that you can devote to doing something like that. So meditation may have something to do with that, right? That is being linked to having the extra time and money to be able to do something like that. Not that it costs much money. It's more about the free time to do that. Another one could be that the type of people that meditate tend to be the kind of crunchy granola types that I used to see all the time in Portland, Oregon when I used to live there, which is the kind of people that, for example, tend to be like vegan and vegetarian, and we know that red meat is associated with heart disease, and maybe it's actually that and not the other thing, right? And so I'm not saying any of those are the actual reason why this would be occurring. I'm just saying there are almost always confounding variables with these that we need to make an attempt to control for as we're doing these studies. Otherwise, it is very hard to say specifically it was that one and not this other thing that could have influenced our outcome. So again, that's what's called a confounding variable, is some other variable that could have influenced things, and just this process of having multiple variables that could have influenced outcomes is just called confounding in general. Okay, and so these observational studies are sometimes the only ways that we actually are able to conduct experiments looking into links between different things, for example, exposing workers to asbestos and outcomes from that, right? Like, I can't say, okay, I'm going to do a controlled experiment where I decide some people are going to be exposed to asbestos and other people will not, and let's just see what happens, right? Like, this is horribly unethical. All we can really do is just see, okay, the people that get exposed to asbestos during their work and the people that aren't, let's compare those two groups, just passively observing what happens with them. So this is not the ideal situation because confounding so often occurs, but it is many times, especially with dangerous or risky things, right? Whether it's treatments or experiences or whatever it is, these tend to be the kind of thing where you kind of just have to do an observational study because anything else would be unethical. Okay, so I think the big point to get out of all of this is that these confounding variables make it nearly impossible to establish cause and effect with observational studies. Now, I'll talk about this more in a dedicated statistics class, but there's been a field of statistics developed called meta-analysis, which is able to put several different observational studies together to attempt to get much closer to this cause and effect, establishing of that cause and effect relationship. But without doing that, all we can really say is that there appears to be a relationship, not cause and effect. Okay, so generally speaking, observational studies cannot say this thing causes this thing, just that they're related to each other.